All right, I think good afternoon, everyone. My name is Rajiv Krishnan. I represent the organization called Matific. We have a very interesting talk today on a very interesting subject called mathematics. The topic is called the language called mathematics, and it is by a very eminent personality, Professor Pant. Just to give you a little bit of context, I'm sure you must have heard about this astronomer slash physicist called Galileo. So Galileo, sometimes back, had made a statement. He said that our whole universe is written in the language of mathematics. Okay, and if you think, deeply about what he said, I mean, you can see that it's almost true. Just to give you a bit of example, if you take the case of COVID, okay, we all know this number called R naught. Okay, R naught is a number which talks about the spread of COVID. If it is above 1, the COVID is spreading multiple times. If it is below 1, the COVID is it's coming down actually. Okay, if you look at any natural phenomena which is happening around us, you need to explain that. For example, the water boils at 100 degrees Celsius, it freezes at 0 degrees Celsius actually. Okay. For explaining anything related to any physical phenomena, physicists have to use mathematical formula to explain any physical phenomena actually. And today, for explaining the whole language of mathematics, we have a very eminent personality, Dr. Pant. Okay, and he's a computational physicist. Okay, which means that he used computation for explaining various physical phenomena. He done his PhD from IIT Roorkee, and his PhD was under the guidance of Mr. Joshi, who was the previous Director General of CSIR. He has been teaching in various well-known institutes in India, ranging from IIT Kanpur to MLNR engineering colleges, to lastly, he was also the Vice-Chancellor of IGNOU, actually. Okay. And after a gap of almost close to 40-50 years, he has decided to establish a movement or a framework called Learning 321. The whole idea of this particular framework is to emphasize something called lifelong learning for future readiness, actually. Okay, and this is one of the goals under UN Sustainable Development Goals, actually. Okay. So with that, I want to quickly run you over the agenda. We have a lot to cover over the course of the next 30-40 minutes, and I'm hoping that, and I'm 100% sure that Dr. Pant is going to make it very interesting. He's going to enlighten us with his thought, and I'm hopefully at the end of this presentation, I hope most of you will have a different view or a different idea about the subject of mathematics, actually. With that, I would like to invite Professor Pant to make his talk and enlighten all of us, actually. Thank you very much. Dr. Pant.
So good afternoon, and thank you, Rajiv, for those initial kickoff remarks. And especially thanks for organizing a thing like this, because very rarely will you see a session with a title, say the language called mathematics, because we normally tend to think of mathematics as a subject, a boring subject, a difficult subject, a challenging subject, a scoring subject, or whatever. And you've kind of done well to begin with what Galileo said, and this is where I've also picked up this thing from. This will not be like a traditional mathematics class. It will be a conversational mode. So I'm talking to you about mathematics. The goal is, of course, to get you to be interested in mathematics and to want to learn mathematics and be able to learn mathematics by yourself. Especially during these COVID times, we have seen that schooling has not been possible for a large number of people, and we don't know when the traditional thing will be available. So there is a agenda that if you get interested enough, you will want to learn yourself. And there are so many tools today, especially technology-enabled tools, which will help you in being able to do this. So anyway, let's get with some stories. So Plato is a well-known philosopher. Aristotle, Plato, and Socrates were the three great people in terms of philosophy. And Plato had an academy. And it is said that at the gate of the academy, it was written, "Let no one ignorant of geometry enter." And even Aristotle studied there, and then Aristotle created his own thing called Lyceum. And you must have seen these are names which educational institutions often look up to this thing. Geometry was considered one of the interesting, challenging part of maths at that time. And that's why Plato said this. And as you know, geometry is attributed to Euclid. And the king at that time, Ptolemy, he went to Euclid and he says, isn't there an easier way of learning geometry? And there's a very famous quote to him that there is no royal road to geometry. Similarly, there is no royal road to mathematics. Mathematics has to be learned, but it can be interesting if you're sort of, looking at it and enjoying it rather than a subject which you have to do because you have to pass and square and so on. And this whole narrative is going to be about stories like this. But let me begin with a very interesting thing. So let's say, take it as a given, that the distance of the Earth to the Sun is 93 million miles. Approximately, you know that Earth is in motion, therefore it cannot be a fixed distance, but typically it is 93 million miles rounded off to a nice number of zeros. The speed of light is again rounded off 186,000 miles per second. So I'm asking you to do a very simple thing. Find out how much time does light take to come from the surface of the sun to the surface of the Earth. I'm saying surface of the sun because there's a whole lot of physics going on between the light from inside the sun to the surface of the sun, and that takes a long time, and it's nuclear collisions and so on. Skip that. Surface of the sun to the Earth, 93 million miles, 186,000 miles per second. How much time does it take? Now, many of you might remember this from your school days and immediately say 8 minutes or so, or approximately 8 minutes. But let's do it from the beginning. So you have 96 million, 186,000. You divide, you cut out the zeros, and you essentially get 1,000 upon 2, which is 500 seconds, which is 8 minutes, 20 seconds. So even if you don't remember it, you can calculate it without much effort. But why is this interesting? This is interesting because if you try to do it in another way, and that is, let's call Roman arithmetic, the way classrooms are written in the school typically, you know, class 5 is written as V, class 6 is written as V and I, class 4 is written as I and V, class 10 is written as X, class 9 is I and X, 11 is I after X, 12 is 2 I's after X, and so on. So it's called the Roman method. It was also prevailing for a long time. If you try to do this by the Roman method, you have to write 96 million in Roman. Just think of it. You have to write 186,000 in Roman, and you have to divide. Now, you can't divide because there are no zeros and no cancelling like what we did. We took 186,000, cancelled 1,000, only 3 zeros remain, that's 1,000 upon 2. There are no zeros there. And this is why Indian astronomy was way ahead of the Western world. Because we had zero, and you know the story of Aryabhata and so on and so forth. But the reason I'm trying to say is that it is a question of the language. The Indian mathematics language had this concept of zero and division and so on. But although the Roman language was perfectly capable of a number of things, including counting, but was not able to do these kind of operations. You see this in all languages. If you're familiar with more than one language, you will see that something is easy to express in one language rather than the other. And this is why it is very important to think of maths as a language. We often in school, we are taught to do a few things which are addition, subtraction, whatever, and that also we fully don't understand, and it remains with us for life. And often the maths teachers are also people who discourage you. The system discourages you. Very early in school, they will tell you, no, you can't do maths. You go to the non-math stream. Why? Because on something, they found you couldn't do some operations because you were probably a greater thinker. Many of you would have known that Einstein was called the slow child because he was not willing to accept what was being said, but wanted to think and verify for himself and trust for himself. So I'll begin with, I'll share with you another story. The idea is to give you a few stories. Very early in school, class 2 or so, you are taught addition and subtraction. In addition, the basic thing is carryover, which makes it a bit difficult. In subtraction, you also do something like that. And a typically amusing situation occurs when you have to subtract from the, let's say, top and the bottom, and the number at the bottom is a little larger than the number at the top. So let us say you have 35 and you have to subtract 19 from 35. So what do? You can't subtract 9 from 5. So you are stuck. And the teacher probably tells you that you borrow 1 and make it 15. And from 15, you can subtract 9. And then you get the answer and everything is hunky-dory. But you will realize that I did this. I borrowed. But when did I return? And you never returned. You were happy with the answer. You got your marks. You went this thing and you never kind of looked at trying to do this, because otherwise in life you're told if you borrow something, you must return it. So this is the kind of metaphor which is used. Why I'm using the word language for maths, because when you're using the word borrow, it is actually a problem creator. In fact, Vijay Mallya probably took this very seriously and he borrowed lots of money from the bank and never returned it. Because he said, this is what my teacher told me, that you borrow something, get your work done, and you don't have to return it at all. There are certain other things also very often that we try to put into some of these things. So for example, to multiply by 10. Very often in early school, you'll be told if you have to multiply by 10, you put a 0 at the end of it. So you have 14, you have to multiply by 10, you put 0 at the end, you get 140. It's absolutely right, you get good marks, you're very happy. But then when you have 1.4 and you have to multiply by 10, you again write as 1.40. It is wrong. Now you are not able to understand what happens to this teacher. Sometimes by putting 0 at the end, it is correct and he or she gives me good full marks. And I did the same thing again and I did not get the marks. It was considered wrong. So the difference between 14 and putting a 0 and 1.4 and putting a 0 is something which is again a question of how you construct. This is like in grammatical, when you use grammar or language, you say, I did not went, it is considered wrong. I did not go is fine. So this is why it is very interesting to see in that. And I'll tell one more example before I move on to other things. And this is very interesting. This I have tried with people who are well educated, including educated in the IITs, got BTech, MTech, maybe even got a PhD or something. There's a crowd, which let's assuming at first time has not heard this question before. And I asked them, what is multiplication? And unanimously, they will answer repeated addition. I said, very good. So 3 into 2 is 3 plus 3 is equal to 6. You got the right answer. Everything is fine. I say, now without changing the rule, what is half multiplied by half? And then they realize that something has got wrong. Sometimes some people even say 1. But then those who know that it is 1 upon 4 are lost, because what did you add? When you multiplied half by half and you said multiplication is repeated addition, you didn't add anything. This is what is the problem. So because we don't really learn maths, we don't really master maths, we don't really conceptualize maths, we end up doing things which are sometimes right, sometimes wrong, and therefore we lose sense of confidence. And this is why it is important to appreciate that these small tricks to do calculation is not the right thing. And especially now, in the age of computer, you have to see maths as something which you do with the help of computers alongside computers. Use computers both to do maths as well as to learn maths. So anyway, so language is, as you've seen, this human language. And many of you who are young know that it is not only the human natural languages which are language. So all of you know that there are a number of programming languages. Depending upon your age, You have heard of Fortran, COBOL, Pascal, C, C++, Java, etc., etc. And if you are very young and don't know about the older languages, you've heard of Python. And you say that this is a programming language, which is different from human languages, but it's called language nonetheless. And this is where gets interesting. So we have specialized languages also. They're sometimes not called full-fledged languages. They're sometimes called jargon or technical terms or whatever. Even if you're in the field of IT, you know there are certain technical terms which you use. Doctors, they use a certain terminology which only doctors understand, or those who have learned that thing. Lawyers have another language, plaintiff, defendant, criminal charges, this, that, whatever, and so on. So the point we are trying to say is that math is a system of various operations, thesis, etc. And there are things which we need to understand about it fully. Because of, see, that why is math so difficult? Because if you look at any other language in the world, every child learns that language by 2 years of age without any formal instruction, by just the proximity of the mother. That's why it is often called the mother tongue. So the mother speaks that language, the child in the care of the mother learns the first mother tongue effortlessly. Depending upon the challenges, learns a second language also, and many more languages if they need, including, as I said, computer languages and so on. But no mother speaks maths. And therefore, maths is not the mother tongue of any one of us. It is therefore an acquired language which we learn. But look at Indians. English is not a mother tongue for us. But by and large, educated Indians are pretty good in English. In fact, most people abroad are surprised that how are you so good in English? So if we can learn English, we can learn maths. And everybody can. And in fact, long ago, you remember, there used to be that book called Rapid Excel English Speaking Course, for which Kapil Dev had become the brand ambassador, and so on. So if all of us can learn a second language, if we treat maths as a second language, we will all be able to learn maths. And all teachers who say you can't or you shouldn't or you won't be able to do this are absolutely wrong, because the science which deals with the brain and learning is called neuroscience. And neuroscience says that we can learn anything at any stage. This is called neuroplasticity. It is called neurogenesis. And therefore, it is not a question of this. The myths that are around maths. Yes, there is one big myth is that men are better in maths than women. I remember when I was young, we used to study in a school, convent school, and the girls corresponding. I was in a boys' school, corresponding girls. The girls were very hesitant about taking maths. In fact, I think they didn't teach maths and science, etc. It was not considered a girlish subject. They were taught history and English literature and poetry and so on. But there is no such thing. Absolutely not correct. Similarly, the thing is that you have to be born with maths. Now, we give stories of people like Ramanujam, etc., who were geniuses, but that's a different issue. But just like everybody who sings and dances is not a born genius in music or dancing, maths also is a set of things which is to be done. There is always, then the thing is that somehow we say that in maths, either you have a right answer or you don't have the right answer. That's also not correct. You may move towards the right answer. The wrong answer will also tell you something which will help you understand why it is a wrong answer. And analyzing that is very important. In fact, I often say this to educationists that to err is human. You know, there's a very famous proverb, to err is human. And of course, it is followed by saying to forgive divine. But what I say is to err is human, and to know why we err is cognitive science. So there is nothing wrong in making mistakes in doing, because if you don't make mistakes, you will never, it's just like going from one place to another. If you have not ever traveled and made a wrong turn or a wrong direction, you will never know how to go. So in maths, if you get the right answer every time, then there is a chance you are not learning anything, because learning is the basic thing, is about making mistakes and learning from mistakes and so on. So these are some of there are many other myths, but these are some of the myths. And all that I'm saying this, it is not true. Anybody, and there are many examples. In fact, there's a very famous example of a lady called Barbara Oakley, who gives a course on Coursera on learning how to learn. And she said that she was mortally afraid of maths. And therefore, she did not study maths, and she studied literature, and she became a translator, translating from Russian to English, but she got sucked into and became a professor of electrical engineering. So this is how it happens. So it is not this too early a labeling that you can or you can't. The question that a person should ask is, what is it that I have to do in order to learn maths? Not that you can do or you cannot do. See, very often we try to tell people that you can't. I mean, it's very common in school. They will tell this very early, etc., etc., and it is all wrong. It is based on a kind of a concept of a fixed mindset that people are born with whatever it is. You might as well say you are born a Brahmin and therefore you can learn. Today, nobody accepts that non-Brahmins cannot learn. So same thing. So mathematics can be learned, and it can be, all that you have to do is what are the barriers coming in the way, and remove those barriers. And those barriers are cognitive barriers. That's why I said cognitive science is about finding why people make mistakes, why they don't do things correctly. Another very important thing is that by making it like this, people forget the joy of mathematics, the beauty of mathematics. And there are two kinds of beauty in mathematics. One is, of course, an abstract beauty, that the way you do this. So even when, for example, let me give you again a simple example. Let's take simple thing, adding numbers 1 to 10. So I can say add the numbers 1 to 10, and you say, yes, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, and so on. This is one method of doing it, which mathematicians will say is a brute force method. But suppose you were able to say, okay, it is 1 to 10. See, 10 and 1 make 11, 9 and 2 make 11, 3 and 8 also make 11, 7 and 4 also make 11, 6 and 5 also make 11. So we have 5 pairs of 11, and therefore the sum is 55. This will be considered an elegant method, a beautiful method. So basically what mathematicians do, or people who appreciate beauty in maths do, is they look at how you are doing a thing. So are you doing it elegantly? It's just like you see in music also, you see the rhythm and the smoothness. In dance, you see whether your motion is smooth or it is erratic, I mean, with jerks, etc., etc. Same thing in mathematics. You can do things in many ways. So this idea that there is only one right answer, one right way is an incorrect thing. You can do it in many ways, and you will appreciate the joy when you see these patterns. Well, in fact, I'll take you to another thing. There is something which is more in terms of philosophy or critical thinking called Occam's razor. Now, Occam's razor is a principle which says that if in solving a problem, I have fewer assumptions, then this is a better thing. So just like, for example, Rajiv gave that example of the pandemic explosion, etc. And he talked about R0, and he said R0 is less than 1, R0 is greater than 1, and so on, which is, of course, as you know, the formula for geometric progression also. AR square, AR cubed, etc. If R is greater than 1, it will keep on increasing. If R is less than 1, it will keep on decreasing. So let us say R is half, then you get 1 plus half plus 1/4 plus 1/8, this sums up to 2. So the point is that the idea of a pattern, a beauty in the pattern, and elegant ways of doing this. Otherwise, you can say, I keep on adding every day's data, etc., etc., and so on. So this is like, it is not only this. I will share with you one more thing, and I can go on and on, but I will share with you one thing which is very interesting. Again, it is very surprising why it happens. Nobody knows why it happens, but there is in mathematics something called the golden ratio. It is represented by the Greek letter phi. Now we are all used to so many Greek letters, alpha, beta, gamma, delta, omicron. So, and in maths, you know, we use pi and we use theta and we use all this. Phi is a symbol used to describe what is often called the golden ratio. And all artists, all architects, everybody is aware of this golden ratio. And this golden ratio is valued just like pi approximately is 22 upon 7 or 3.14159. This golden ratio is approximately 1.618. But I will go a little deeper and try to tell you something more about this golden ratio. So this golden ratio is that when you have two numbers, A and B, and the numbers are such that A plus B upon A, which is the larger number, is the same as A upon B, then these numbers are in a golden ratio. It turns out that so many beautiful patterns obey this. All architects are aware of this, all building people, all designers, all this thing are aware of this kind of a ratio. It is also found in nature. You will see the sunflower petals are like that, many other things. And this also comes from another thing completely different. So I gave you from this ratio, and then you can solve a quadratic equation and get the answer. There's another way of doing that, and this is called the Fibonacci sequence. Now, Fibonacci sequence is a very interesting sequence, and from a pure mathematical term, we say, let's take 0, add next number 1. So 0 and 1. Now, these two are added to become 1. So then 1 and 1 is added to become 2. Then 2 and 1 is added to become 3. And 3 and 2 are added to become 5. 5 and this are added to become 8. And so on. This is called the Fibonacci sequence. We also have a version of it in Indian ancient mathematics as well. Fibonacci sequence is normally given to you as an example of rabbits multiplying, and they multiply very rapidly. And so what happens? But the beauty is that as this Fibonacci sequence goes, and when you take any of these large numbers, let's take the n plus 1th term and the nth term in the Fibonacci sequence and divide them, the answer comes out to be 1.618 or 5 or whatever. This is where people see beauty in maths. That's things which are completely different. Same thing you will see with pi. Pi is defined as the ratio of the circumference to the diameter of a circle. But you will find so many expressions with pi, so many, infinite series coming up with pi squared upon 12 and so on and so forth. So this is the aspect of the beauty of this thing. Recognition for math. So I'm trying to follow the structure that I had and not get too deviated because I can go on and on. Recognition for maths, very interesting. There is no Nobel Prize for maths. There are many stories about it, but the acceptable story is that Alfred Nobel thought that maths has no use. But maybe in school he also had a tough time with maths. So he thought physics has a use, chemistry has a use, medicine has a use, and literature is useful, and peace is, of course, very good. So he thought of these 5 things for which he would say there's something for humanity. He never thought that maths has anything to do with serving humanity. In fact, he was quite wrong, because eventually it is maths which is going to do the biggest service to humanity, and we can talk about it. But that doesn't mean there is no recognition. So firstly, sometimes once the economics prize has been introduced, lots of mathematicians got Nobel Prize under the economics category. Herbert Simon, so others got this because they did something in economics, mathematical modeling, and that kind of became, or in computer science or something, that came into as sort of. But in maths, there are 2 well-known prizes. One is called the Fields Medal. The Fields Medal is, again, a very prestigious thing only for this thing. Unlike the Nobel Prize, I think there's an age limit for it also, and it's given every 4 years. The thing which is interesting is the last 2 field medalists are Indian. And this is why it is even more interesting to understand that we have a natural disposition. Forget even Ramanujan or Aryabhat or Panini or Bhaskaracharya. Recent last 2 field medals are given to people of Indian origin. And there is another prize called the Abel Prize, which is again, but because of the difficulty of this kind of a thing, these are not much talked about. So what is maths? Is it a language? So I have been also seeing when I was in university, 1962 to 1964, I was still by the same question. So people who did physics, chemistry, and maths were given BSc degrees. People who did physics, economics, and literature were given BA degrees. It was the same maths, same question paper, same syllabus, same thing. It was not as if the BA maths was studying Shakespeare and maths or something else, philosophy and maths, etc. No, they were studying the same maths. And then when they went on to do the masters, if they came from a BSc stream, you were called MSc in maths. If you came from an art stream, you were called a MA in maths. So this kind of a thing about maths has always been there, and we are not very sure. So what I would like to say is that think of maths as a way of thinking. In fact, all subjects that you learn are actually trying to tell you their way of thinking. The world comes to us as one. The world comes to us, we experience the world as whatever it is. But the way we look at it is very different. And that is where you can say there's a mathematical way of thinking, there's a physicist's way of thinking. They're very closely connected. There's a chemist's way of thinking, there's a biologist's way of thinking, there's a philosopher's way of thinking, there's a spiritual way of thinking. And these are ways of thinking. So a mathematician thinks in a certain way, follows logic very carefully. And for example, we talked about Euclid's geometry and so on. And then what happens is that what has become very interesting and is a puzzle, this is a thing with lots of people discussing, if mathematics is pure imagination and pure logic and pure construct of the mind, why does the world conform to mathematics? Initially, Rajiv talked about ratio R0. It's a pure mathematical concept of a geometric progression. How does it apply to an epidemic? How does it apply to populations? How does it apply to something? This is what people find very amusing and interesting. That mathematically, you imagine something called a negative number. You find it, not only the worse, you imagine square root of -1. Pure imaginary thing. It's in fact called imaginary number. But you cannot do electrical engineering without the use of square root of -1. Now, this is exactly the interesting thing about maths. So therefore, the two things that maths, which is not useful today, might be useful tomorrow. And this is why I wanted to say in the beginning, when I said about Plato, that Plato said that those ignorant of geometry need not enter. I'm saying those who will not be well versed in mathematics will find themselves perishing in the 21st century. The future is about mathematics. If you see AI all around you, or you're hearing AI all around you, how does that AI work? It works on mathematics, it works on linear algebra, it works on matrices, it works on this thing, it works on statistics, it works on Bayes' theorem, it works on all that. You cannot survive in the 21st century with understanding. You can be a passive object who cares, who says that I don't know, everything is Rabdi Maya and he alone knows. But if you want to be a person who's understanding things, then you have to be up and fluent with maths, and therefore you have to have conceptual understanding. That topic is map of maths. So see, very often when we see arithmetic, algebra, geometry, we think that this is what maths is. No, this is like, the iceberg. We said you see only 1/10 of what you see is the iceberg, 9/10 is beneath it. And that is where the Titanic crashed. Most of us will crash because we will know only arithmetic, algebra, geometry, whereas that 9/10 of mathematics, which is be knowing, we wouldn't be knowing and not therefore be able to negotiate the world of the future. Calculus is one of them. Calculus is a very important part which takes you further. Then logic studies, probability, things which are not taught at all, topology. The latest things in science and quantum computing, etc., talking of topological. New materials are talking of topological, new kind of thing. Then there is fractal geometry, self-similarity, replication, etc., and so on. So now I want to wrap up because I want to get closer to getting comments from you. So the next 10, 15 minutes, I will try to summarize. So first is that we have maths phobia. And overcoming maths phobia is the first thing that we need to do. Maths phobia is caused by a number of things. You see, what happens is that there is sometimes teachers create maths phobia. Many maths teachers like to show off that, they are very clever, they know this and you don't know it and you will never be able to know it, you are a dunce and so on, so forth. Sometimes parents create that because parents were afraid of maths when they were in school. They try to, in a sense, quote unquote, infect their children with maths phobia. Sometimes the peer group may do. The smarter people who were there, they may try to say that, okay, you are no good, etc. You took so long. You could not do it mentally. You have to count on your fingers, etc., etc. But the answer is very simple. The solution to any phobia is to overcome it. The solution to math phobia is to basically learn some math, do some math, and move on. There is no other option that is there. And there's an expression in this thing that is, in fact, many of you who are educators may know, there's something called mastery learning. So master maths, don't let it be. See, if you do a maths paper, you should not say, I don't know whether I got it right or wrong. You should know whether you got it right or wrong. And the expression for that is he who knows and knows that he knows. So you have to become that. And this is where it is very important, because all that you have to do is to see where you are getting wrong, where is the problem, and so on and so forth. And once you have sorted that out, you can do that. And like in many of the things, we say maths is a question of practice. Like many languages are all practice. If you don't practice using a language, you won't be fluent in using that language. No matter you know, and that's why, in fact, in language, we distinguish between reading, writing, listening, and speaking. So you could be reading, you could be listening, but to write and speak, you have to have a higher level of knowledge. These are called production skills. Reading and listening is consumption. Very important to understand that. Similarly, in maths, these are these four stages. We don't distinguish that. We must be able to distinguish whether I can read maths, whether I can hear maths, or whether I can actually write maths and I can actually speak maths. I'll give an example. I don't know Sanskrit at all, but I have learned many shlokas in Sanskrit by heart. I even learned the first slok of the Bhagavad Gita and the last slok of the Bhagavad Gita. So first slok says, Dharmakshetre, Kurukshetre, Samvita Yus, Mamka Pandva Kim Kurvas Sanjay. Last slok says something about this thing. I can tell you, Ano Bhadra Kritavo Yantu Vishvata, which means let noble thoughts come to me from all directions. But because I don't know the language, I cannot say let no stupid thoughts come to me from any direction. Because for that you need to know. This is the problem with maths. If you know the language of maths, you don't have to wait. You will also create your own questions. Whenever you're confronted with something, you'll say, how do I express this mathematically? And you will become a better planner, a better engineer, a better doctor, a better civil servant, whatever, because you are now looking at things, because maths has now become part of your language. So it's not enough. See, for example, I will share with you, you will see that in our political discourse, we very often say equality, equality. Now, if you have learned equality in maths, you really know it has to be equality of certain dimension. Now you say all men are equal. How can all men be equal? What they're equal in what? Their height, their weight, their volume, their race, no, they're equal in something, which spiritual or which God has said or whatever. Therefore, you can do nothing with it. So this is the interesting part. Why mathematics becomes so important? Actually, Lord Kelvin is a very famous physicist who said this, that if you cannot talk about something in numbers, you really don't know anything about it. You're just talking imaginary. You cannot do a continuous improvement. Now, I want to just now wrap up by two kinds of things. One is we had talked about the millennium problems. I don't want to spend too much time. All that I want to say is you can Google millennium problems if you like. All that I'm saying is mathematics is not a done thing. There are a large number of problems, still unsolved problems, for which huge amount of prizes have been given, awarded, and so on. Similarly, same thing for, is maths discovered or invented? This is another very interesting debate, and you can go and look this up on YouTube. You will see lots of brilliant scientists talking about it. See, often we say in science we discover. So Newton discovered gravitation. He didn't invent gravitation. So the force of gravitation were there, the laws of gravitation were there, the apples were falling, the planets were moving. Newton discovered that. But in maths, sometimes it is difficult to say whether you're discovering or inventing. So when you create calculus, you're inventing. When you think of square root of -1, you're inventing, and so on. And therefore, it is just to give you a little bit of an idea that maths is not a settled subject. It is something which we continuously discover. Tomorrow you may discover the maths of democracy, the maths of a life well lived. So what is it today? We will talk of religion, spirituality, but tomorrow you say, no, I have mathematically said that this life A was better than this life B, as we can say for many other mathematical things. I now want to wrap up by saying how you can learn maths, and especially on your own. This is very important because the access to teachers and schooling and traditional thing will be limited in a severe way. We don't know what and how, but fortunately, maths is something that you can learn a lot on your own. The way is go step by step. So I will share with you a few things. And one of the most well-known methods for learning maths was what was called the Kumon method. Kumon method is, you must have seen, chances are in your towns, city, etc. There are some Kumon centers, etc. I am not advocating that as a brand, but what I'm saying is it was founded by a Professor Toru Kumon from Japan. And Professor Toru Kumon was a professor in a university, and his son wasn't doing so well in maths and school maths. And while his wife said, it's all right, some people are good in maths, some are not good in maths, Toru Kumon couldn't accept it why his son cannot be good in maths. So he said, I have to find some method of getting this fellow into maths. And he created a whole method. And the principle of the method is very simple. Step-by-step incremental thing. Now, what happens today in school teaching is we move to the next stage without his being comfortable with the previous stage. So let's say we began with numbers, addition of numbers, addition of two-digit numbers, addition of numbers where you have to carry over something. Then you talk about fraction. Now, he's not understood fraction. When you say 5 upon 9 plus 7 upon 12, he just adds 5 and 7, 12 and this, and you say, no, this is not right. He's not understood this. Before he's understood it, you start teaching him decimal, then square root, then sine theta, cos theta, then quadratic equation. Now, the point is, if he doesn't understand the previous things, he's getting a whole lot of additional things which he doesn't understand, and therefore he is mortified of the subject. So the first principle is that it is graded step by step, and you have to do what is called mastery learning. And mastery learning is a word which was told by Benjamin Bloom, the great educator. And he said that different people can take different time to learn a thing. You have given the same time. On this day, I will teach this day I will teach this, and I will keep on. But every person is different. Every person's rate of learning is different. Every person's interest is different. And therefore, what you have to do, and this is what Toru Kumon did. So Toru Kumon said, let me put the whole topics that they have to learn step by step. And each topic has to be mastered before you go to the next topic. And this is what they do in the Kumon centers and so on. Now today, with IT, you have many products which help you in learning that. So they are personalized, they allow you to do mastery learning, they allow you to repeat again and again. And that is why I'm saying with the use of technology today, everybody can learn maths to the extent that they want, given that time and facility. So you have a large number of products. I don't want to suggest any specific one, but there are many of them. But the important point is that you have to get the motivation, the confidence that you can learn, and there is absolutely no reason why you can't. And the idea, one mistaken notion that has happened in education is we try to make maths easy. No, don't make it easy. You let it be what it is. Let the person become confident and resolve all quote unquote cognitive barriers and actually learn the real maths. So instead of trying to make it simple, make it easy, etc., let it be what it is, but take the person to be able to do that. So I will stop now for a while, and I think we are just about 15 minutes or so. So I'm happy to respond to questions, comments, observations, whatever, and so on.
Sir, I will ask the first question, sir, actually. Am I audible?
Yes, yes.
So the question is, if you look at our teachers, okay, particularly in the primary grade, they are not specialists in mathematics. They are generalists actually. Okay, and if you have to make a subject like mathematics very engaging for our little children, how do you think they should do it? Because they have the time pressure to finish the whole curriculum in 10 months, okay, and they are not a specialist in mathematics. So for making an abstract subject like mathematics interesting to somebody in a lower grade, like let's say from first standard to fifth standard, how do you expect them to do that actually?
See, firstly, I'm saying get the teacher out of the equation.
Okay.
So I am a promoter of self-learning.
Okay.
And all children, see, before children go to school, they know which is bigger, which is smaller. You don't have to teach them big and small, just give them 2 sweets and they know which one to pick up. They know that 4 is more than 2. You just give them 4 toffees and see that they. So maths is something which is very sort of. Now you can do that. In fact, I have actually created something which I call nano learning. So I have created a whole series from class 1 to class 10 of step-by-step movement. So it begins with counting from 1 to 10, reverse counting 10 to 1. Counting from 10 to 20, reverse counting 20 to 10. Counting odd numbers, counting even number. You see, if we, as you said, if we rush through because teacher has no time, then no learning will happen. See, for learning will happen at your time. This is very important to understand. The difference between broadcasting and learning is you can do your broadcasting, including whatever, but learning, and that is why MOOCs are not so successful, because broadcasting you can do at 0 cost, at very low cost, etc. But learning happens in the brain of the person. And what does learning mean? It means overcoming the cognitive barriers to learning. If you haven't found out what the barrier to learning is, and all of us remember that in fractions, I gave you some example, in decimal, I gave you example. Unless you sort that out and let him become fluent in it, you will not move. You will get answers. You may have another Baiju coming in, you have something else, etc. But learning will not happen. Learning only happens when the barriers to my learning have been removed. And that is why we need teachers. So but what happens? Technology allows us to do all that personalization, which a teacher can't do. You said a teacher has to deal with 40 students, take across, etc., etc. You can't do that. If you could do that, and I have no hesitation in saying Benjamin Bloom, etc., in their research have done this. It's called personalized system of instruction. In fact, I have played with that model in a pre-computer age when I was teaching in IIT Kanpur. So for a physics course, I did this, that I created. So that means I create a completely different quiz for every student. And everything that he does, he has to, because it has to be personalized to what he has done and the next question for him. Now, by simply saying half of you failed, it is no use. Nobody's learning anything. So now what happens, and you are more aware than others, that the technology exactly is doing that. Technology is helping people to move at their own pace and making sure that every intermediate step has been taken care of, done, and achieved. The educational foundations of them have been made by the educationists called Benjamin Bloom and many others. There was called PSI, Keller Plan. Many of these things exist, which were there. But pre-computer days, it was very few. Only very few committed teachers could do this for a batch of 20 students or 40 students or something. But if you want to do it for millions of students, the only answer is computer-based instruction to support that thing.
So I have a very interesting question from one Honey. I don't know the last name. She asked, the question is, as you said, mathematics is discovered. How come mathematics symbols are also discovered? Is it not invented?
See, mathematical symbols have become, in a sense, by common agreement. Now, you're seeing this today in coronavirus, that people are adopting Greek symbols for all the alpha, beta variant. So the mathematicians were the first one to adopt that. They adopted this. There were 3 things. See, first they adopted letters of the alphabet like X, Y, Z, etc. in algebra. So all unknowns were X. If you had more than one unknown, you had X, Y, and Z, and so on. Then you had, if the thing was a little complex idea, you took something from Greek alphabet. So you took theta and phi and so on and so forth. There is no universal kind of agreement. It is true that a lot of mathematics was developed by the Greeks, and therefore it took on. We talked about Pythagoras, we talked about these people, so those things happen. But tomorrow some completely new notation may come up. In the new generation of emoji walas, they may create a completely new notation for triangle, etc., etc. So it would be great to see an emoji generation person creating new icons for mathematical symbols.
So I have another question from Abhishek Singh. So his question is, how to motivate a student who loses all hopes in mathematics, even after relating mathematics with real life in classes and motivating them on regular basis, actually?
Yeah, see, you have to identify, see, what happens is that we have to identify what motivates the person. Now, there are theories of motivation. There are broadly 4 kinds of motivations, things which motivate people. One is money. So money motivates everybody, but to a certain extent. After a stage, money is no longer a motivator. But I have no hesitation in saying I'm part of the IIT system. A large number of people who want to go to IIT is not because they think they will learn something great, but because they will make more money. So I have no hesitation. So money is a big motivator. And then the next motivator that is there is respect. We want to be respected by people. So if you know mathematics, you are more respected by people than you wouldn't. If you were, you could be in a society where mathematics is not respected. The third is the thing called power. So do you get power? Now, Francis Bacon said, knowledge is power. Mathematics is great power. And many of you know that E is equal to mc square. When the atom bomb was made, people saw the power of E equal to mc square. Until then, they thought these scientists talk general. Finally, what people want is achievement. So you can do something which somebody else cannot. And that is what is a motive. So you have to look at what motivates the particular child and get them to be able to do that. The motivation can be very different for different people. So some people like to solve puzzles. So then if you give them mathematics that, look here, you know, this thing, X is not telling what it is. And I am going to find out X by finding out from his friend Y. What is their story? What are X and Y doing together? And then I can solve simultaneous equations to get both X and Y. Now, it depends. The person may have no curiosity, but he may have an interest in beauty, pattern, whatever. So this is why it is very important that the role of the teacher, as I said, is not a broadcaster, but is to get the person interested. And there are many, I have seen many videos of people. There's a very well-known person who got interested in maths with calculus. Prior to that, he was not at all interested in maths. Arithmetic algebra didn't appeal to him, but calculus he found very fascinating. It's called Keith Devlin. He's one of the most well-known professors in maths. So there are many different people which motivate. So you have to kind of fine-tune and see what motivates the person.
So one other question is from Chitra Rola. The question is, children in the early years enjoy solving math problem, but as they go to higher classes, phobia develops. What could be the reasons?
Yeah, so as I said just now briefly, see, the point is sometimes the phobia comes because of pressure, condemnation. See, we don't realize teachers make remarks like, you won't be able to do this. What serious psychological effect it has on people, we don't know. There have been experiments where they had 2 groups of people. One who were told you are very good, you will do it. And the other were told you are no good, you cannot do it. And the ones who were told you are no good couldn't do it. And the ones who were told you are good could do it. So there is a lot of motive. That's why I say learning is also about what is going on. It's not about content. So in fact, in my other lectures on learning, I actually talk to them about Stephen Covey's Habits of Successful People. So it's a completely different thing. But if you look at the Stephen Covey's Habit of Successful People, first he says, begin with the end in mind. So why I am learning this, right? You learn Pythagoras theorem, but why are you learning this, etc. So, and similarly, you say, first understand, then seek to be understood, and so on. Those habits are, so there's a lot of personality issues over here that we are dealing with humans. We are not programming. See, I am in this field, so I can also be a machine learning engineer and program a machine to learn. But programming a machine to learn and getting a human to learn are two different things. Now, unfortunately, we have been treating in our education humans either as machines or as animals. So like you have dog trainer and this thing, etc. We wanted to, you have to start looking at them as humans. The moment you start doing that, it will become very different.
One other question is, what is the advantage of concept like backward counting?
See, it is a question of patterns. The whole idea is that you will see that when you do patterns, you can have things in ascending order, descending order, etc., etc. So very often we might need to look at, like we said, begin with the end in mind. So we are saying, what is the end? Then what is? Then you know more. It is the concept of recursion. So if you want to see something, you want to go backwards. So I want to know factorial n. It says, okay, it is n times factorial n minus 1. So what is factorial n minus 1? It is n minus 1 times factorial n minus 2. So backward counting, etc., is all a question of pattern. So if you look at a higher level, we're talking various kind of patterns. Therefore, alternate counting, even counting, odd counting, counting of third, counting by squares, sum of squares of numbers, etc. All these are looking at various patterns in doing this.
Nischal wants to know your views on abacus.
My view on abacus is that it was an old system of counting, which was very successful. And in fact, I have personal experience that in the 1970s, when the programmable calculators had become this thing electronic. So I was in Hong Kong and I bought an electronic programmable calculator on my way back from Canada. And the person who was selling it did all the business calculations on his abacus. Although he had a calculator to do the conversion of Hong Kong dollar into US dollar into this, that, he was using the abacus. He was not so comfortable with the electronic calculator, which I was buying. So it's a nice tool of a certain point of time, but it is limited to that. At that time, it was a great thing, and so on.
Other question was, can you please say about linear equation in two variable chapter? I mean, how to make it interesting?
You see, one of the simplest ways in which it used to be taught, I remember when I was young at that stage, I think my father probably told me something like this, that one person says to another, if you give me half of what you have in your pocket, I will have 50 rupees. The other person says, you give me 1/3 of what you have in your pocket and I will have 50 rupees. So how much money did each of them have in their pockets? So it's a question of, as I said, you can create see, as you said, problem is that most early school maths teachers are not in love with maths. They're doing maths because it is a job they have to do. And I think they are equally relieved that class is over when the students are relieved that class is over. But if they enjoy that, it will never be this thing. So I have always enjoyed maths. Fortunately, I was good in maths also. I got very good marks, etc. Even in my BSc, I got like 144 out of 150 or 146 out of 150. I enjoyed maths. I enjoy maths even now. And in fact, if you ask me, all the evils of society today are because they don't have enough maths to deal with those problems. If they dealt with the problem in a mathematical way, the thing would be much less.
I have one interesting question from Nischal again. His question is, what do you prefer, Indian system without calculator or British system with calculator?
No, third one, the computer
Which
with
is,
artificial intelligence.
Okay. Okay, we'll take one more last question, sir. After that, we will wind it down.
Okay.
So this is from Vidhi Khurana. She asks how to motivate students to study algebra.
Very good. See, again, as I said, we have to find out what their motivation is, what curiosity. But suppose you take curiosity. So in fact, all of us love detective stories. So algebra is all about detection of somebody who's trying to hide the identity. It's an unknown. It doesn't tell you what it is, but it interacts with the world. And therefore, there are other things that you get to know. And from that, you are able to find out what the unknown is. Sometimes you subtract, sometimes you divide, sometimes you do this thing, etc., etc. The other important part of algebra is that it allows abstraction. I remember when I was young, for the first time I learned y is equal to mx plus c. I was looking all straight lines. What is the value of m? What is the value of c? When I learned that a circle is a square plus y square is equal to a square, I was all finding out the a of the various circles in the world and where they are. When I learned that this is for the origin, but otherwise it is x minus a square plus y minus b squared, then I was looking for where the center is, a, b coordinates. So I think it's a question of getting them excited. Mostly it will be sharing your excitement. So if you're excited about something, you will share your excitement, and that is infectious. Just like laughter is infectious, like telling jokes is infectious, similarly solving maths problem will become infectious. Not like the coronavirus.
So I think we almost like 4 p.m. So I will probably want to summarize this actually, I think I wish I was your student, okay, to be very honest, because you bought my college days, okay. I wish I was a student in your class because I would have never bunked your class for sure, okay. I would have listened to your class you have a very, I don't know, very infectious way to make this whole subject of mathematics very easy. Okay, I've never seen anybody speaking so passionately about the subject of mathematics. I can tell you with 100% guarantee that pretty much everybody on this session must have felt the same about mathematics. Actually,
thank you.
I think I want to thank you very much for this very exciting session. I mean, I forgot the fact that we have already reached 4 p.m. because time flies away actually, and I would definitely want to invite you once again because we had like a limitation of 500 participants for this session, and we almost completed with 500 people. So I would definitely want to invite you once again and probably do this session all over for our remaining participants actually.
Okay.
So with that, I will probably just take 1 or 2 minutes of everybody's time to talk a little bit about Matific, and I'll wind it up actually. So just to talk a bit of Matific, is my screen visible?
Yes.
Okay, but somehow, just a minute, sir, actually. Okay, so I just want to spend at least the next 2 minutes to just give you a little bit overview about Matific. So we are a digital math platform for primary years. So we use gamification as a concept for teaching mathematics. So is my screen visible or is it kind of stuck actually, sir?
No, we just have the headline, what is Matific, and a wave.
Oh. Okay, so somehow I think my screen is stuck for whatever reasons. I'll explain it. So we are a digital math platform for primary years. So we use gamification as a concept for teaching mathematics. So like you rightly said, Matific is a company which was founded by some well-known mathematician, and they want to address this problem called math anxiety. So math, as you said, is a very abstract subject. So one way to make it interesting is to create a platform which uses a gamification to make it look very, very interesting for all the students. So if you see the screen over here, we have a lot of interactive math activities. Okay, so we call it games. Okay, so basically these are activities which can be used in the class for teaching various concepts. Like for example, these activities are aligned to multiple curriculums in India. It's aligned to CBSE, ICSE, IB, IGCSE. It's also translated into multiple languages. So we want to create an environment which is very fun, engaging way for the teachers to teach mathematics actually. So that so that the whole subjects can be learned in a very interesting way by the students, and the math phobia can be overcome by the students actually. Sarah, can you just move forward? Move forward. Yeah. And the good thing is that we also have a very detailed reporting for most of the teachers so that they can focus on their teaching, and the reporting will give detailed information about how each student is doing and can take corrective action. And the beauty is, Matific works on any device, whether it is your desktop, your laptop, your computer, whether it's your tablet or it's on a digital screen, it works properly. And you don't need to have an internet connection to work on Matific. It works in offline mode, actually. So our belief as an organization is that if you can do the foundational part of maths very properly, then the student's life is made. Okay, he will start liking the subject, and over a period of time, that math anxiety go away. And we believe that the way of doing it is to make the whole math teaching learning more fun and engaging. And we use a concept of gamification for doing that, actually. Okay. So with that, I want to thank every participant for being this part of the session. Feel free to reach out to us if you are interested in learning more about Matific and how we can help you. I'm sure some of you must be considering using some digital platform for teaching mathematics or primary grade. So feel free to reach out to us. I want to thank Prof. Pant once again for making this session very interesting, very enlightening for all of us. Thank you very much and have a nice session.
Thank you. Thank you, Raj.
Thanks.